At conditions which are associated with normal puffs, realistic puffs, the levels of aldehyde are very low, and in fact there was no difference between 3.3 and 4 volts. Now we're doing some extra experiments at 3.6 volts, but even when you compare 3.3 with 4, the amount of aldehydes that were released were the same. You see an increase going at 4.2, and of course at 5 volts you see a very high peak, and the levels are about 7 to 8 times higher at 5 volts compared to the levels at 4.2 volts even, let alone even at 4 volts, it's a huge difference. Next. But I think we must explain to everyone that formaldehyde is everywhere. So formaldehyde is present here in the environment where we're sitting. Of course, here we also have the vapor, but it's present in our house, and that's why the WHO has set the upper limit of formaldehyde levels associated with clean indoor air. So when you're just sitting at home for 24 hours doing nothing, and you just breathe, you are exposed at levels of 2,000 micrograms per day, which are about 3 times lower from what we found in our experiment when you are taking 600 puffs from the e-cigarette in the first study that we did. Next. Another issue that was recently published was the issue of diacetyl acetylpropyl, and I'm sure you all know our original study. It was done by the researchers at Harvard University, and they found that several of the liquids contain diacetyl. The levels were not really high, and of course the major problem with this study was that they didn't even mention that these chemicals are present in tobacco cigarettes, and they provided no risk assessment based on acceptable limits. So next, compared to what we found, the levels that the Harvard study found were much less than ours. But our study showed that there are some liquids which have very high levels. Approximately 40% of the cases, the levels were much higher than what NIOSH is accepting as a safety limit of exposure. And so I will repeat that it's a potential risk, and I think they should be completely eliminated from e-cigarettes. Next. For toxicology, we have seen in the recent years several studies which are evaluating and have found several mechanisms by which the e-cigarettes could cause damage, such as inflammation, DNA damage, endothelial dysfunction, gene activation, and so on. Next. But there are some problems. For example, this is a study which showed that nicotine may cause chronic obstructive pulmonary disease. In mice, of course. So you can see that they found that that was an effect of nicotine. When the liquid didn't have any nicotine, the effects were similar to the control animal, so nothing bad happened. But when they used nicotine, 18 milligrams in this specific example, they found that several changes in the respiratory tract of the mice. Next. But it is important to understand, and that's in that study they tried to simulate the levels of nicotine that a normal smoker has. But there's a big difference between human smokers and mice smoking, and it's coming from the metabolism of nicotine. So the half-life of nicotine in mice is only 6 minutes. So it means that in 6 minutes, half of the nicotine you administer to the mice is degraded, is metabolized. In humans, it's 2 hours. Moreover, the half-life of cotinine is very short in mice and very long in humans. This means that in order to give a dose similar to a human, to have levels similar to a human, you need huge doses. They were using 0.4 milliliters of liquid to mice who weigh 200 grams. So on a per kilogram level, it's something like a vapor vaping 100, 200 milliliters per day. It can happen. Next. Another one again found some problems in the blood vessels of the lungs from exposure to e-cigarette. But go next. Here are the findings from different nicotine levels. Next. So the nicotine concentrations used in the experiments range from 16 to 1600 milligrams per milliliter. But it's important to understand next that the levels present in humans is 0.03. So they were exposing the cells at tremendous levels of nicotine, which are not even compatible with life. No one could survive such levels of nicotine. They would die. Next. And a more recent study said that they can cause asthma. So a lot of people are focusing on such studies. Next. Next. But they seem to ignore that we have human studies in asthmatics which are showing that there is improvement in the asthma condition when a smoker switches to e-cigarettes. And this is a study by Ricardo, next, who found that even after 2 years of follow-up, there is a significant improvement in spirometry, so it's an objective measure of the respiratory function, which is maintained even after 2 years. Next. Some other studies which you may have seen, they have been in the media, and recently that was also on the first page of the Sun newspaper in the UK, is that electronic cigarette use can cause aortic stiffness, and this is a risk factor for disease. Next. So the authors even claim that it can have important long-term implications. Of course, they tested the aortic stiffness before and after using the cigarette and before and after smoking. And of course, the comparison was between smoking 1 cigarette 5 minutes and using the cigarette for 30 minutes. Next. However, it is important to say, first of all, that the guidelines on how you measure aortic stiffness dictate, next, that you should not smoke, eat or drink coffee for at least 3 hours before the measurement, because they know that these stimulants affect the measurement, so they create false results, basically. Next. The other issue is that the findings of this study are very similar to the findings when you drink coffee. So in this study, they asked people to drink coffee with or without caffeine, and they found, of course, that in people drinking coffee with caffeine, there was an increase in aortic stiffness 30 minutes after drinking the coffee. Of course, you know that this is an acute effect, but caffeine is not a risk factor for heart disease. Next. The same findings have been observed when you give NRT, so oral nicotine in the form of gums. The same increase in aortic stiffness has been observed. Next. But when people quit smoking with NRTs, and you measure, of course, the resting aortic stiffness, there is a significant improvement in the aortic stiffness, which starts at 4 weeks, and there is a further improvement at 8 weeks after smoking cessation.